To another video, guys. Today we're going to be talking about the fundamentals of Python. So let's get started, man. So open up Google Chrome and search for Anaconda, because this is what we're going to be using to run our Python code. Awesome. So go to products, go to individual edition. It's open source, by the way, all free. And if you're a beginner, this is really all you're going to need to understand the fundamentals of Python. So click on download, and then click on the Mac OS one or the Windows one, or the Linux one, depending on the particular operating system you might be using. Well, for me, I'm using a Mac, and basically I already have it installed, so I'll just boot it up right now. Okay, cool. Cool, so just click on the Jupyter Notebook launch and should come up. Awesome, so it's on. Good, so go to your desktop. I'm going to create a new folder. And I tell you what, I'm going to change the folder name to Python. I'm going to enter the folder. I'm going to create a new Python 3 notebook. And I'm going to call it lesson 1. Awesome. So first thing we're going to do is just type as I type. And we're going to print, open quotation marks, hello world. And then press shift enter and hello world should come up. Alternatively, you can also click on kernel, restart and clear output, and basically this will default to it being before the code ever runs, and you can click on run here, and that works as well. So you just wrote your first Python code. Congratulations on writing your first Python code. Now let's type some comments. So comments are intended to improve the readability of your program and are ignored during program execution. So basically the code doesn't run. So a comment in Python looks something like this. This is a comment in Python. And basically nothing changes. And if you, this is a comment in Python. If you just click shift enter, the thing doesn't do anything. It's just to let the programmer know what's going on. Okay, the next thing we're gonna do is talk about variables. And a variable is a named location to store data in memory. Variables can be used to represent values, data sets, or even files. The variable name is usually chosen to be something meaningful, intuitive, and self-documenting. So Python has some rules on variable naming. For example, every variable must begin with a letter, or the underscore character, which is this, or it must begin with a letter. The name should not contain any spaces. And after the first letter, it can contain any combination of letters, numbers, and underscores. The name should not be a keyword, operator, or delimiter. For example, the keyword cannot be or, it cannot be if, it cannot be for, right? These are keywords in Python. We'll go into them in more detail later on. But for now, just remember that it's got to start with a letter or an underscore. And it should not have any spaces. And after the first letter, it can contain almost anything it likes. So for example, I'll just give you a variable example. For example, number likes, which basically stands for the number of likes, for example, of something, and we'll just define that to be 0. And then the variable can be updated over time. For example, you can change the variable equals to num likes equals to num underscore likes plus 1. And now if you run num likes, you can check that it's actually no longer 0, whereas in this case it was 0. Oops. Okay, let's run this again, and it was 0, right? And basically when you run the next two lines, it becomes 1.
Alright, just to point out, the reason it was 1 earlier on is because this had previously been run. So right now, if you just run this, it's 1 because you already ran this line here. So that's why it changes. But if not, if you run this line again, it becomes 0. Okay, so let's just take that out. So just to reiterate, every variable in Python has a name, which is this, a value, and also one more thing, it's a type. So there are number of different variable types, and we'll talk about that later on. But in this case, the variable type of num, and you can check every variable type by typing the word type, open brackets num, and you will get integer. Okay, so the next thing we're going to talk about before we go into the different data types in Python is constants. So a constant is a value that is expected to remain the same over time. So a constant in Python is named in the uppercase. For example, if we wanted to define the value of, say, pi, which is 3.142, we would put it in capital letters. I don't know if I can zoom in. Right, so it will be in capital letters. So this value is typically not going to change. So basically what's going to happen is, if you wanted to calculate the circumference, and I'll just define a variable of r, and I'll just define another variable called circumference, and I'll just do 2.r.pi, and area equals to pi times r, and I'll run this, and you'll get the circumference of 3.419998. Now the advantage of using a constant is that if I wanted to change the value of, say, pi, I could change it easily here, and this would change as well. And if I wanted to change r, I could just change this to 6, for example, and this would change. Okay, and you would change the circumference, and it would change the area as well. If I change it back to 5, everything changes back, and the area changes as well. Okay. Now if we were to type everything in manually, which we could, like say 3.14 here, and 3.14 here, the disadvantage of this is that if you want to change, we have to change everything. If I want to change it to 3.142, I want to change it to 3.142, I'm going to change both, and obviously I may make mistakes and forget, so that's the advantage of using, say, a constant or a variable. And just to reiterate, a constant is typically one that doesn't expect to change over time, while a variable typically expects to change over time. So now let's talk about some of the common data types in Python, which I've just showed you. There's one here that's integer. I'll actually delete everything. I'll delete this as well. Now there are a few different data types in Python. So there is an integer, there's a floating point. Actually, I'll just give you some examples. So I'll just define a variable, integer, and I'll just give -10, for example. And if I type integer, you get int. And then there's also float, but now float is a keyword, so I'll just give it floating point. And it's basically like a decimal, or a number with a decimal. And if I type floating point, you get float. Okay, and now there's another type called boolean, which is a true or false thing. So now if I go type boolean, it shows bool. So you can see there are a number of different data types. I'll just go through a few more. And for example, there's a string, and this is basically anything within quotation marks. And then if I go type string, I get str. There's also a list. So list example, I'll just put that, and A, B, 4, and false. Okay, and if I type list underscore example, I'll get an output list, and that shows that this was a list, and if I type dictionary course, and I'll just type IS111 for example, and title programming. I'll explain more in detail what a dictionary does later on, but for now just keep this in mind. And if I type dictionary, you get dict, and there's also a set, which kind of similar to a list, looks kind of similar, but slightly different because it uses curly braces, and you get set. So those are basically the main data types in Python. Now now we're gonna go through, these are like just the main data types. So now that you know that, we're gonna go through the next part, which is like arithmetic operations like plus, minus, divide, modulo, exponential, floor division, so that you can actually do stuff with Python. So for example, 3 plus 5, and you can actually just enter and it will show 8. So you can also do 3 minus 5, and that's subtraction, and you can do 3 times 5, and that's multiplication, and you can do 3 divided by 5, which is division, and you can do 3 percentage sign 5, which is the remainder, which is 3, which makes sense because the remainder of 3 divided by 5 is 3, because the quotient would be 2. Okay, so and now if you want to do 3 to the power of 5, you can do that, which is 2, 4, 3. And you can also do floor division, which is the integer division, so it rounds down to 0. So again, 3 divided by 5, how many times of 5 does it require to fulfill the value of 3? And answer 0 with a remainder of 3, and if you do that, it's 3. So basically this is also can be seen as like the quotient. So 5 floor division 3 should be 1, and then that's basically the quotient, and 5 percentage sign 3, it should be 2. Okay, so now we're done with like the main operators. I'll just show you another example. 2, okay, let's just say I want 2 divided by 4 times 3. Basically it's 2 divided by 4 first, so that's 0.5 times 3, which is 1.5. And then now I just want to point out one more thing. So exponent expressions should be evaluated from right to left. So let's just say in this case, it's not 4 to the power of 2 to the power of 3, it's 2 to the power of 3, then to that to the power of 4. So 2 to the power of 3 is 8, 8 to the power of 4 is, well, I actually have no idea, but yeah. If you don't believe me, you can just try it out. 8 to the power of 4. Hold up, did I just make a mistake? Sorry, my bad. This is 2 to the power of 3 is 8, then it's 4 to the power of 8. So 4 to the power of 8, yeah, my bad. Okay. Yes, awesome. So you can try one more example. 2 plus 3 times 4 minus 5 over 6 divided by 7 to the power of 8, for example. And this should still work, and basically, no idea what it is, but basically, yeah, Python can do a bunch of complex calculations. But anyways, this is not really that important. So yeah, just to show you all that this kind of works. So I'm going to delete everything. And now we're done with operators. We're going to talk about random number generators. So random number generators can be used for games, can be used for captures, can be used for statistical sampling, cryptography, and they're all pretty important. So let's talk about them. So first thing you want to do is import random. Then there are two ways to generate numbers. So first thing you do, let's store this in a variable. Type random.random, and basically random is like a library, and random is a function within that library. I'll explain this later on, but just run that, and now r can be any value. And if you run it again, hold up. Okay, you know what? This is not a good example. Okay, so if you run this every single time, it just changes. Let's just delete this, and it just changes. Another way, if you want to put it like within a range, you can put rand int, and then you can type the numbers 1 and 10, and every single time you run it, basically it gives a different number. Okay. Now we're done with like that. Let's talk about other things with regards to Python. Hold up, give me a second. Next thing we'll talk about is logic control. So basically, what's a condition in Python? If-else statements. Basically, I'll just give you an example. In Python, there's such a thing as if-else statements. And for example, if 5 is greater than 3, print 5 is greater than 3. So basically, if this condition is true, you'll print this. So this will return a boolean, which we went through just now. Or it can return, and booleans are basically, again, just to show you all, it's a boolean, and even if you type false, it's also a boolean. So it's either a true or false, and those are the only two values a boolean can be. And 5 greater than 3 returns a boolean condition that is true, in this case true, and therefore this line of code will run. So I'll just show you all 5 is greater than 3. Now let's change this to 1 is greater than 3. Now obviously 1 is not greater than 3, so this boolean will return false and nothing will run. Okay, so that's basically it. And now I'll just show you all the next part, which is an else statement. If you type else, basically if this is not true, then say print whatever number is not greater than 3. Okay, and that will be printed out because this was not true, so this runs instead. Alright. I just want to point out one thing. You all might have noticed I indented the code here. And basically, blocks of code in Python are grouped together based on indentation. So indentations in Python are usually tabs, or 4 white spaces. So basically what I'm trying to say is Python is pretty important to just use tabs and just be careful about that. Okay. Now there are other operators, like there's greater than, there's also lesser than, there's less than or equals to, there's greater than or equals to, there's also equals, and there's also not equals. We'll talk about we'll see more examples of this later on. And I'll actually show you all a quick exercise based on a random number generator. Okay, so first thing we want to do, I'll just delete everything, and what I will do is I'll create an input, and I'll type what, sorry, give me a second. Okay, guess the number, and 2. Right, so what I'll do is I'll type this into a variable called number, and nothing happens, so number will be 2. So what I want to do is guess a number between 1 and 5 inclusive. Okay, so this is actually, I'll call this variable guess, and I'll call a number equals to random.randint, and I'll give it a number between 1 and 5. So And after that, if number equals to guess, print you have guessed correctly. Oops, you're supposed to put this in quotation marks. Oh, sorry. What am I doing? Else, print you have guessed incorrectly. The random number is... Now we're going to talk about this more, but hold up. Pause. Oops, so can only concatenate integer. Okay, hold up, give me a second. I'm just gonna have to change the type to string. And let's just put 3. You have guessed incorrectly, the random number is 4, actually. Yeah, so y'all can see, if I put 2, you have guessed incorrectly, the random number is 2. Hold up. I guessed 2 and I still guessed incorrectly. If guess equals to number, hold up a second. Keep guessing incorrectly. Let me just hope I get it correct once. I'll just keep guessing 4. Okay, and I still guessed incorrectly. So hold up, give me a second. Guess number. Okay, I think this is not recording it as a string. Yep. Okay, sorry, my bad. Okay, great. So basically, for some reason, this is being recorded as a string. But basically, you have to change it back to an integer here, because this one is an integer. And basically just now when I was entering 4, it was recording as a string, so I gotta do type conversion to change it to an integer. So I know I just skipped the concept here because I did 2 type conversions here and I didn't talk about it. So type conversion is very simple. Basically, if you have an integer that's 2, this is an integer, right? So but let's just say your integer is 2, but you want and basically if you enter type integer, what happens? It gives string. Okay, so let's just say you want to make this an integer. What you do is type the words int and surround the inner variable with brackets, and now it becomes integer. So you just changed it. Of course, if it was like this would now throw an error because you can't have alphabets and stuff like that, because that would not be an integer. If it was like if it was 23, for example, it would still work because it's still an integer. However, if it was this, would it work? Pause the video. It will not work because this would be a float. So what you want to do is change it to float, and it would throw a float. So same thing here. If it was instead, let's just call this a string, and let's just say this was 20. Now, if I go to type string, it would throw string. But let's just say I wanted to make an integer. I would do this, and then it would now be an integer. Sorry, my bad. String, and let's just say I had the number here 230, for example. And now if I went type, it will get integer. But if I changed it to string, making it type conversion, now this would be a string, and basically this can be used as a string. So in this case, in the above example, what I saw was that if guess was an integer, the integer of guess. So basically what I did is I recorded the input and it gets a number, which is 4. If the integer of guess equals to this number here, which is random.randint equals to 1-5, which this was a number which was 4 in this case, if it's equal, and it is, then print you have guessed correctly. If not, and
I guessed incorrectly, they'll print you have guessed incorrectly because the number is now 1 and we guessed 4, the random number is, and in this case I had to change the type of number from integer to string so that I can concatenate it with you have guessed incorrectly, the random number is 1. And that's all for this particular program. I hope you understood it. If you didn't, no worries, we're gonna have many more examples moving forward. So okay, let's do more practice with if-else statements and boolean. So x equals to 5, y equals to 10 if x is greater than y. And now we'll give two separate conditions in if-else statements. Basically, right now, previously we had one condition, we're going to add two conditions. And y is lesser than or equals to 10, we're going to print A. Elif not x does not equals to y, print B. Else print C. And if nothing happens, just print D. So before you run the code, I'm just actually gonna restart and clear all output. Okay, great. So nothing is here. Now I just want you to guess or not guess, but tell me what's gonna happen. You know, if x is greater than y, and y is lesser than 10, lesser than or equals to 10, print A. So this will not run because x is not greater than y. Okay, so basically this condition states that both of this must be true. So this doesn't work. No. So then we elif not x does not equal to y. So x does not equal to y here because 5 does not equal to 10. So not equals to 10. So in this case, this condition is true. So the not wants you to return true if it's inverse. So this one, since it's true, the not will give it a false, make it false. Whereas if this was false, and this return a false, and this not, this will be printed. So in this case, C will be printed because else neither of these are gonna work. So C is printed, and D is also printed. So CD. Let's give another example. X equals to 5, y equals to 10. If x does not equals to y, oops. Actually, you don't have to use the brackets. It's up to you. X does not equals to y, print A. And in this case, you know, that kind of holds true. And now we'll write another if statement. If x remainder divided by 2 remainder is greater than y, the quotient of y divided by 2, print B. So, okay. Elif negative y to the power of 2 is lesser than 0, print C, or square, okay, print D. Now D will always be printed, so let's check. X does not equals to y, that returns true, print A, A will be printed. Now if x divided by 2, the remainder is 1, is greater than y, the quotient of division by 2, which is 5, which is not true, so B won't be printed. Now let's check the next one. Elif negative y square is smaller than 0. This can never be true because the square of anything will always be positive, right? So in this case it's 100, so B and C won't be printed, so only A and D will be printed. Oh wait, C will be printed. Give me a sec. Negative y, negative 10 square. Hold up. Oh wait, my bad. So the exponential sign always comes first. So this is one of the tricks in Python. I'm sorry about it. So basically, 10 to the power of 2 is 100. So negative 100 will be less than 0. Basically the power sign comes in first, and C will be printed. So if let's just say this was negative 10, then C would not have been printed. But I was wrong on that, so but B will also be printed in this case, because now this divided by 2
is -5, and that is indeed smaller than 1, which is what you will get the remainder of 5 divided by 2. So sorry about that. It's ACD which will be printed. This is true. This is true. And this always prints. And you can check it here. So, okay. So I hope you understood more about booleans. Alright. Now, I'll talk more about this particular condition, which is kind of a problematic one, with if not something, right? If not x does not equals to y, print x equals to y. So you can see nothing was printed. In this case, just to remind y'all, oops, sorry. X equals to 5, y equals to 10. If not, x does not equals to y, print x equals to y. So basically, why is this printed? So this condition is false, correct? X does not equals to y. So if this was just like this, it will be printed. However, if you take the opposite, that means the not, if this returns a false basically, then this will run. If you put if not here, that means you want this to return a false. Okay, for example, x does equal to y, and you can put 10 here, and it will indeed print. So this is basically the same as writing if x equals to y, print x does equal to y, and it'll be printed twice. Now I'll show you something more interesting, and I'll put this as a comment actually. Not x or y equals to not x and not y. Okay, so now if x or y equals to if x or y, if x and y, if x and y. So okay, I'll actually not talk, I'll talk about that later, but the point is that, oops, okay, the point is that if this or this is true, if either x or y is true, this statement will run, because you only need one of them to be true. Whereas if x and y, that means this statement will only run, this condition is only true if both x and y are true. However, if you put not x or y, both x and y needs to be not true, because if either one is true, then this will return a true value. And you can also say if not x and y, only x and y need not be true for this to both be untrue, because if one of them is untrue, the other one is true, this is going to return a false value. So for this not to work, this needs to be false, and only one of them needs to be wrong for it to be false, hence all works. Okay, it's kind of an interesting little concept. I'll actually give you an example. So, okay, let me think. Okay, let's just say x equals to 11, y equals to 4. If x is greater than 10, and y is greater than, smaller than 5, print A. Okay, print both conditions are true. So both conditions are true in this case. However, if I change y to 6, nothing runs. And if I did change this to 5, we'll only change this to all. So basically now this is true, this is not true. And now I'll change this to one of them conditions at least are true. Okay, and that works, because now if x is 11, y is still not true, this is still not true, y is 6, but yet this is still printed because one of them conditions are true at least. So one of the conditions are met. Now if both are true, what's going to happen? now one of the conditions, one or two of the conditions are met. Okay, so that's more accurate actually, because now in this case both are true and they run, and if I change this to 3, it still runs, because even though this is not true, so long as this is true, it works. Now I'll just show you what happens if I change it to 9. Now neither conditions are met, right? Now nothing prints. But if you change this to 5, one condition is met again, and now it runs. So this explains this concept here. So what about not? Okay, so now in this case, if you do this, both of this have to not be met. So basically this has to be, say, 6 or 5, and this has to be 11. Now neither is printed, right? Okay, but I'll just type neither condition are met. So this condition here is met, so I actually change it to 10 or 9 to make it less confusing. Neither condition are met, right? Because it is not this or this. Okay, so now if I change it to n, still nothing is printed. Still neither condition are met, because in this case x is indeed smaller than 10 and y is indeed greater than 5. So if I change this to 7, however, now this condition is no longer met. This returns a false. This returns a true. This returns a, hold up, x is greater than 10, x is 9. So this is false. This is also false. So neither condition are met. But if I change this to 4, this is now going to return true. This is going to return false. So overall this will be false. And this will be at least, sorry. At least one or more condition is not met. Okay, hold up. So this will be true, this is not true. And if you change this to 11, this won't be printed because both are met. Whereas if you put this to all, still nothing will be printed. Whereas if this was end, hold up, that's kind of confusing. Wait, x is greater than 10, that's true. Y is lesser than 5, that's also true. So this needs to be 6. So this will be false, and this will be true. But because it is an n, then this will return false, so not, and then at least one or more condition is not met. So basically what I'm trying to say after that very complex explanation is anytime you want to set this condition to be at least one or more, you will use this, not x or not y. And if you want to do neither condition, then you would use or. Okay, and yeah, basically if you want both conditions to not be met and only for that to run, then you have to do this or this. This kind of complicated logic, you should try to avoid it in reality. It's just for fun now that we're learning. But you know, and basically this will only run if this is 4, and if this is if this is 6, and this is 9, and neither condition is met. Okay, but anyways, I just want to say that this complex logic should only be used sparingly, if not at all, when you're actually coding, because it's kind of a stupid thing. But anyways, yes, hope you enjoyed that, and yeah, we've talked a lot about logic, and we'll talk about our next concept, for loops and while loops, which is the next part. So first I'll delete everything. Okay, great. So first of all, loops allow you to repeatedly do something until you're satisfied. So a loop can be you want to practice 10 sets of papers, you want to do 20 push-ups, or you keep doing push-ups in a loop. So the key thing about loops is that they need to end. And so in programming, or in Python rather, there are two types of loops: for loops, while loops, generally. So okay, so I'll actually show you all some examples of a loop right now. So let's just say you wanted to, let's just import a random library again, and let's just say you wanted to generate a random number between 1 and 10, and you want to print it. And now you want to do that many times. So you'll copy and paste this as many times as you want. Oops, my bad. And then you'll have it 4 times, right? But let's just say you didn't want to copy and paste it. You want to just keep randomizing it. So what if you want to generate and print 100 random numbers? You can't just copy and paste, right? So what you would do is say for I in range of 100, and I'll explain what this does later, but it'll go from 0 to 99. R equals to random.rand int 1-10, and I'm going to print R. And now you'll print it 100 times, and if I do it again, it'll be all different, and again, it'll be all different numbers. So that's why you would typically say use a for loop. Okay, one more thing. What this means, okay, the end value, which is 100, is not included. So basically what this does is it generates integers from 0 to 99. So it'll be from, I'll just leave a comment here, 0, 1, 2, 3, all the way until 99, and 100 is not included. So if I put 1 here, it'll instead be from 1 to 99, and if I put 0 here, it'll be from 0 to 99. And that's how it works. Okay, so just to remind you all on that. And one more thing about Python, I have not mentioned this earlier, is that in Python, numbers start from 0, and in computer science, basically, numbers start from 0 and ends, and basically starts from 0 and not 1. Yep. Okay. Alright, so I'll just try an interesting question that called the fizz test, which is an interview question, and basically it goes something like, let's change this to a markdown. Write a program that prints the numbers from 1 to 100, but for multiples of 3, print fizz, and for print fizz instead of the number, and for multiples of 5, print buzz. For numbers which for numbers which are multiples of both 3 and 5, print fizz buzz. Now this is a pretty popular question, and you can pause the video and try it yourself, but if not, I will teach you how to do it. So I in range of 1 to 101, because I want to print, so I'm just going to print all the numbers first, and you see I printed all the numbers. Now if I divided by 3 equals to 0, and the remainder of I divided by 5 equals to 0 as well, then print, I'm just going to take this out, print I, and I'm just going to check that this is correct, and print fizz buzz. And this should be 15, 30, 45. So basically all the multiples of both 3 and 5. I'll work with that case first, and I'll print fizz buzz instead of that. And now, if it's only divisible by 3, I'll actually put elif. I'm going to print fizz, and it's only divisible by 5. I'm going to print buzz. Else, I will print I, and there you go. So 1, 2, 4, 5 buzz, fizz buzz, 15 is fizz buzz,
I should be correct, honestly. But yeah, so 2039 fizz bus. Yep, I should be correct. But anyways, this is how you solve the fizz bus question. So let me just go through it again. So for I in range 1 to 101, so you'll go through all the numbers from 1 to 100, and if it's divisible by both 3 and 5, and the remainder is 0, that means because of n, both these conditions will be fulfilled. What will be printed is fizz bus. If it's only divisible by 3 and gives a remainder of, if it only gives a remainder of 0 when divided by 3, but not 5, you'll print fizz. And if it only gives a remainder of 0 when divided by 5 but not 3, you'll print buzz. Else, only the number will be printed. And that's how you solve this question. And that's one way to use the for loop. Pretty cool, right? So anyways, I'll delete that. And I'll take a look at other examples. So there's another way to exit the loop. Let's just say you wanted to exit the loop completely or skip the loop. Okay, so for example, let's just talk about breaking through, exiting a loop completely using a break statement first. And the other example is to skip part of the loop before continuing using a continue statement. But let's talk about the first example first. So for I in range 10, if the remainder of I divided by 7, has a remainder of 4, you'll break. So this code won't run, it will exit. So we'll print all the numbers up to that point. So at 4, when I divided by 7, the remainder equals to 4. Because I divided by 7, quotient 0, remainder is 4, hence the code stops running. And therefore only the first 3 numbers before that will be printed. Okay, so just to remind y'all, if I didn't do anything, everything will be printed. If I added that statement inside, I remainder 7 equals 4, will break, and you only get the first numbers before 4. So another way is to skip the loop using a continue statement. So in this case, let's just say if I wanted the code to run for everything except 4, what I would do is for I in range 10, if I goes to 4. So you see that the syntax is very, very similar. Instead of break, I just put continue. So every number will be printed except 4. You can see 3, 5, and basically this condition is met, so you skip the code for this particular part of the loop. Okay, great. So hold up, give me a second. Alright, so now we've done that. Let's look at some more examples of for loops, some more things that for loops can do, and some questions basically. So first of all, let's look at how you're gonna print. Okay, we'll first delete this. Okay, let's okay, I'll tell you what. Let's try to print negative numbers in descending order or in ascending order. So I want to print from -10, print -10 to 0 using a for loop. Okay, so for I in range, what am I doing? Wait, give me a sec. Okay, sorry, you know what? Print 10 to 0 using a for loop. So we'll start from 10 and we'll end at 0, and you need to put -1, which basically means that the for loop will print in reverse, and you can print I. Now if you wanted to print from -10 to 0, I believe, oops, not it. You can do this, and you'll print from -10 to 0. You can also use 0 to -10. I believe this should work. And
you'll get from 0 to negative 10 because it starts from there. Oh, okay, sorry. You're gonna need to print from 10 to 0 then. You can actually go from negative 10 to 0, and I believe you won't need this, and it should still work. Yep. So just to remind y'all, this one will not be included because that's how for loops work. So, okay, let's try to create a program that takes in a positive integer and prints from that positive integer to 0. Okay, so input as positive integer prints from positive integer to 0. Okay, so just say positive underscore integer equals to integer input a positive integer. Oops. And then for I in range, positive underscore integer -1. So basically this goes from the positive integer to -1, and I want to reverse it because now I'm printing from the positive integer to 0. I'll print I, and there you go. So let's just say 20, and now 20 to that. Now I want it to be on the same line, so I'll put another condition, end of the line, I'll just put a space, and if I put 20, and it'll be printed on the same space. Basically, then it won't be on a separate line once you add this thing inside. You'll tend to pick this up, and if you wanted to know exactly how to print things on the same line, you can just Google how to print on the same line in Python, and how to print without new line. So you can scroll down, and here you get it, n equals to this, and that's basically how you do it all the time. I don't memorize this, I don't think anybody does. So next, let's try creating a for loop that prints the sum of square numbers. Okay, so we'll just, again, we'll do the same thing as this, positive integer. And then sum of square, we'll create a variable and equate it to 0. For I in range 0, positive, okay, you know what, I'll just call this another variable number so you don't get confused. I equals to I square, and then sum of square will just be at I, and you can just print sum of square. Oops, okay. So let's just say 5. So this will be 1 square plus 2 square plus 3 square plus 4 square plus 5 square, which is 25 plus 16, 39, 39 plus 9, 48 plus 2 plus 1, I think it should be 51. Oh wait, what? Am I retarded? Probably. Wait, oh, I see. Wait. No, I'm correct. Hold up. 1 square plus 2 square, 5. 5 plus 9, 14. 14 plus 16 is 30. Oh, right, because it goes until 4. So, let's try again. So if I put 6, then it will be 55. Yeah, 55. Okay. Sorry. Let me try that again. So basically what happens is that if I put 5, it'll be 1 square plus 2 square. And stuff like that. And actually, we can show it statement equals to this. And you can say statement plus equals to string of I concatenate with plus sign, and now you can also print the statement. And just stop this. Let's try again. Okay, so if it's the final statement, you wouldn't want this. So what you want to do is you'll use what we learned earlier to skip the thing. If if I hold up, give me a second, is less than number minus 1, or rather is equals to numbers minus 1, then sorry about this. If we'll just do this, else we'll do this. Well, sorry, let's try that again. 5, and then hold up, give me a second. Oh, okay, sorry. If square root, sorry. Okay, let's put this as square, and then just, yeah, okay, great. Okay, great. So you can say statement, and then once the for loop is done running, you can see all the squares basically, and then you can say at the end, statement plus equals to string sum of square not sum of square actually. It's wait, is it sum of square? Hold up. Okay. Let's try that again. Yeah, correct. So you can take this away and put it below. And yeah, so if you put 20, you can see all the numbers and the sum of squares all the way until 19, which 19 square is 361. And anyways, from 0 all the way to 19, you can get the sum of squares till then. Now if you want to change it to basically the number that you enter, just put a +1 here, and if you put 20, it'll be all the way until 20. And if you put, like, say 5, it'll be all the way until 5, and it's 55. Cool. So those are the examples for for loops, and we'll move on to our next concept. Next, we will take a short break from for loops. We'll do an exercise called the Palindrome Checker. And this will kind of be a lead-in to our next topic, which is like string manipulation, or just a part of string manipulation, which is kind of a big part of Python and any programming language in general. So what's a palindrome checker? So let's change this. You know what, let's delete everything. A palindrome checker is code that takes in a word and checks whether it's a palindrome. Okay, and that's all really. So I'm actually gonna show you how to make a palindrome checker because I don't think I've gone through it yet. And basically we'll just start with user input equals to input word, and then oops, my bad. And then word equals to user underscore input dot lower, and this is basically a helper function that converts all the characters within the string into lowercase. And there's also other helper functions, but basically if you ever need to know what a Python helper function is, you can just Google. It's really the way all programmers do it. And now what you want to do is, if word, and what this condition basically checks for is if the reverse of the word is equivalent to the current word, print true. Else print false. Okay, so for example, the word let's just try a word that's a palindrome, and it's true. Okay, so let's try that again, and let's just try a word that's not a palindrome, and it's false. Okay. Okay, why don't we try return true and return false. And now we'll stop this and try again. Ah, sorry, my bad. So this doesn't work because this is not a function. I'm so sorry about it. Okay, what is a palindrome? Okay, so let me explain what I did. Alright, so well, why is this being printed out though? Okay, it doesn't matter. Alright, the point is that what I wanted to explain is this. So what this -1 does is that it reverses the word. Okay? Now, there are other ways to manipulate this particular string. So right now word is Hannah, right? So if I wanted to extract the characters from this string, I'll just create a new variable called extract. I'll put a word here, and what I can do is, let's just say I wanted to extract the first two letters. I'll put 0 to 2, so 2 is exclusive, so you'll only extract HA, and extract should be HA, right? And if I wanted to go from the first letter only, then I'll put 1, 2. And if I wanted to extract until the fourth character, then it'll be, first, second, third, fourth. So fifth again is exclusive. So the last digit, basically, it'll tell me how many steps I want to take. So if I put 1, it'll just be the same thing. But if I put 2, it'll jump by 2 characters every single time. So basically what happens is it goes from A and then it goes to N. So actually, to make it clearer, I'll just leave this to 0, and then we'll see it's H space doesn't count the A because it jumps by 2 to N, jumps by 2 to A. So if I just take it out completely, it becomes H, N, A, and nothing. So if I put 3, it becomes H, N, and nothing. So the word could be longer as well. Let's just give a much longer example. Just a bunch of gibberish. And for example, A, D, the fourth letter, then the seventh letter J, then the 10th letter J, then the 10th letter D, then the 14th letter D. And it jumps by 3 every single time. And that's basically all there is to this string manipulation thing. If it puts -3, it goes from the back. So, wait, does it? No, I think -1 basically just inverts it. Hold up. So if I take this away, it should give it everything in reverse. If I just put -3 here, hold up, S. So yeah, this makes it in reverse. If I put it from 0 at the start, what it does, so again, this -3 gives it a step from -3. However, if I put a 0 here, it basically implies that it should start from here, which doesn't make any sense because, I mean, it makes sense, but basically once you get the first character, trying to go back 3 steps leads to nothing. So yeah, that's that, and that's why it's A. Whereas if I put something like a 8 here, 0, 1, 2, 3, 4, 5, 6, 7, 8, so D is 8, and then goes to A, and then it goes to J, and there's that. So yeah, so that's all there is for string manipulation. Now let's go on to our, well, before we go on to our next topic, what I'll do is I'll talk a bit about while loops. So a while loop is a very interesting concept. It's similar to a for loop, but it's basically something that runs while the condition is gonna hold true. So while something happens, so let's just say for while n is less than 10, you'll print n, and n plus equals 1. So let's just say in this case we set the value of n equals to 0, And you can see what happens is that n is less than 10, n gets printed, it increments by 1. I don't think this works, yeah. It increments by 1, and then the value of n becomes 1 now, and the n is printed again, and so on and so forth until it's 9, and then it's incremented by 1 to 10, and now this condition no longer works, and the loop stops running. Alright, so now we'll move on from this topic of loops, which is a really interesting topic, and don't get me wrong, there's definitely many more things about loops, but I think we've covered most of it. Okay, so our next topic will be on functions, a very, very important topic that you definitely need to learn about, and every programmer needs to know about it. So what is a function? A function is a block of organized code, okay, that can perform an action. So I'll actually just give an example of a very simple function. So I'll just put a comment, so return square of x, so you know what this does. And answer equals to x square, and return answer. Okay, I know that you would be like, what, isn't it just simpler for us to type this every single time? Yeah, that's correct. It would be in this case because this function is very simple. But now let's just say it was more complicated. You would need to, a function would be useful because it's a block of organized code that can perform an action, and you can reuse it over and over again. And it's going to be easier as your code base grows to use functions. So let's try it. Compute underscore square 4, and you get 16. So because 4 squared is 16. So that's basically how a very simple function works. Let's try another simple function whereby we'll do compute string sum. Okay, so let's just say you enter in a string which is x, and basically I'll just title this string so it's more obvious and easier to understand. So I'll use a for loop for I in string. Okay, you know what, first I'm going to define a variable called sum equals to 0. Actually sum is a Python keyword, it's a function, helper function, so I can't use that. What I'll do instead is I'll call it total, and then total plus equals to integer and I, and now I'll return total. So let's try that, and I'll put 4726, and the answer is 19. 4 plus 7 is 11, plus 3 plus 2 is 13, 13 plus 6 is 19. And that's just an example of a function that you can reuse anytime. So if you want to try computing another string sum, you can try 3100, which should be, sorry, my bad, it needs to be a string. It'll give 4, that's correct, because 3 plus 1 is 4, plus 0 is 4. Okay, so another thing you can do is we'll do an exercise right now. Okay. Let's try a function called is palindrome, which we have gone through earlier, and x. And basically, if word equals to x dot lower, assuming that you take in always a word, and it may or may not be capitalized. But if you know for sure that it will not be capitalized, you can just skip this thing. But we'll just keep that for now. If word equals to word colon -1, return true. And and then what you can do is else return false. So let's try it. Is underscore palindrome, and let's use the word Hannah. It's false, and that's true. Anna, that's true. Lionel, that's false. Wait, yep, that's correct. It's false. Let's try capitalizing Lil, and that's true because of x dot lower, and there you go. So that's an example of a function. Let's try another one, which is it a pangram? which is kind of similar to this right here. But what we'll do is that a pangram is a sentence that uses every letter of a given alphabet at least once. Okay, so it needs to use all 26 letters at least once. Okay, and a quick test case we can try here. Oops, hold up. Is actually we can Google this. Pangrams. Okay, this looks interesting. Hold up, I know a very, yep, this is great. A quick brown fox jumps over the lazy dog. Apparently uses every character in the English. They uses every letter of a given alphabet at least once. Wow, that's interesting. I'm just gonna assume that this is correct. I don't think this uses a C though. It's a letter that uses every letter of a given alphabet at least once. Hold up, give me a second. It's Pangram. Wait Okay, I'm assuming this is correct, but does it use the words? Yeah, it does, Yeah, I think it is. Okay, anyways. How do you check for pangrams? It's very interesting, actually. What you want to do is make sure that you replace all the spaces within it as well. So it's kind of similar to the palindrome idea. It's just that now you need to replace all the spaces with nothing. So basically, word equals to x dot replace. Again, another Python helper function. And then you can chain it to lower. And let's try that first and see what we get. Right. So it's underscore pangram. And let's try it with this. It's not actually that similar, but yeah, okay. So what we'll need to do is we're gonna need a list of alphabets. A, B, C, and so on, right? Okay, and so on and so forth. But another way to do it, which I think is easier, is just to create a very long string and we'll just use that instead. Okay. And for character in alphabet, if character not in word, return false. Otherwise, this code never runs. And return true. Okay, name alphabet. Oops, sorry. So this is true. Now, the way the code works is, we convert the word to lower. Then for character in alphabets, if character not in word, you return false. If this code never runs, true will be returned. Now let's change it to something that's not a panagram. So let's just take out this word. I don't think there's any other B's, so it's now false. So I think we need more test cases than just this two, but for now, I think you kind of get the idea. Alright, so now we've done some string manipulation and functions. Let's try another more example so you kind of understand functions a little bit better. Okay, so let me think. What other topics? I mean, what other questions can we give? Okay, let's try to mask a mobile number. So basically, what I want you to do is create a function that masks the mobile number of somebody, and basically, the first four letters need to, the first four digits needs to be changed to an asterisk. Okay, so let's do that. And for I in string mobile number, so I'm assuming that they put it in integer form. For the first four characters, print this. And now, recall what I said earlier about the n, it will be printed on the same line. And then for the next four characters, just print it. But what you want to do is make sure that the n thing is there so that you're all on the same line. And now, return I. So let's try this. Cool. So the return I is basically just the output. Although what you can do is actually, I actually wouldn't do it this way. You don't have to return that. I actually will do it. I'll just put it new underscore number, which goes to this, and then what you want to do is replace this with plus equals to this, and then that should work. Yep, it'll be a string in this case, and that's the new mask number basically. So moving on, let's try a more complicated example. Let's create a function that calculates the row of lights. Okay, you know what, that I think is too complicated. Okay, cool. So that was it on functions. Alright, so you guys kind of get functions, and we'll just delete all these examples. Okay, cool. So our next topic is on lists, which is a very important topic in Python, and we're going to need to cover it in depth. Hold up. So a list is a sequence of elements. It is iterable, just like strings are. It can contain elements which are of different data types. In contrast, strings are composed only of a sequence of characters. Lists are also mutable in Python, just as strings are... strings are immutable, but lists are mutable. So basically, mutable means you can change them after they are created. Some examples of lists, I think I may have showed you before earlier in the video, but I'll just create some. So this is an empty list. This is a list of strings. This is a list of... that was a list of integers. This is a list of strings. And yeah, so on and so forth. So I'll just create one more example to show you a list of different data types. Oops. Okay, so let's run that. Just like strings, lists can also be sliced. So this is a difficult one, but I'll just create another list example for x, and I'll give you a list of 1a. Try to make it as confusing as possible, okay, because this will really help you understand it. So now I've even created a list within a list, even though the list within the list only has an element, an empty string. Oops, what did I do? Okay, great. So this will really be interesting. So now x, 0 gives 1. So this is the first letter. If I did this, it'll give from the second letter all the way to the 8th letter, because the last letter is not inclusive, just like in strings. And there you go. You can also reverse things, like in strings, put -1, and basically what happens is that it tries to start from 2 and it can't go to 9, whereas you can do this. And now you reverse the thing, and it goes from 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is E, all the way until the third element, which is B. And that's correct. Now you can also skip, and there'll be less elements, so you go E, you skip by 2, and so on and so forth. So again, if you want to access elements from the front, you could, and you just get the first elements, and then you can extend this to the back. Then if you wanted to reverse things, you could as well. You could put this at 0, or you couldn't actually, you have to indicate that you want to reverse the sign, and then you could. Cool, so that's about list manipulation. To concatenate lists, it's very simple in Python. You can just, I'm just going to create a new list. Z equals to 1, 2, 3. W equals to 4, 5, 6. X equals to Z plus W. And now if I type X, I get 1, 2, 3, 4, 5, 6. And there we go. Okay, so that's how you concatenate lists. Now, there are other very important things to do with this. We're not nearly done. Please continue watching. 1 B C 6. So I'll just show you all how to iterate through a list. For I in X, print I. So very similar to string really, and this is what happens. You can also do for I in range length of X. So the length of X in this case is 4, so the range essentially will be range 4. So again, 4 is exclusive, so it goes from 0 to 1 to 3, to 1 to 2 to 3, so 0, 1, 2, 3, and everyone will be printed as well. Oh wait, now that didn't work. Why? Because this range is a number, so it goes 0, 1, 2, 3, that's what will be printed. What you should do instead is put X here, and then you'll print, because now it's X 0. Basically this is accessing the first digit, x1, first element, x1 will access the second element, x open bracket 2 close bracket will access the third element, and so on and so forth. Okay, so now that that's done, I'll show you some list helper functions. So there are a few interesting ones. So for example, length of x, and they'll return the length of x, LENX. So max x will return the biggest element, which won't work in this case for a very specific reason, that they are strings and integers. So we actually use the example of W, or actually I'll use the example of W, and it should return 6. Okay, and if I type min, it'll return 4. And if I type sum, it will add all together 4 plus 6 plus 5, which is 15. Just remind you all, W is this one. Actually, you know what, I'll cut this out, and I'll cut this out, and I'll run this, and we'll change this to X, and it'll be 21, because it sums everything. So just a few key ones again. Minimum X now is going to be 1, maximum X now is going to be 6. Okay. Another one that's very important, and I would say that this is kind of the most important one, is append. So the way you append something is you add something to the list. So if you want to append 7, now X will have 7 to the end of the list. Because lists are mutable, you can change them. And then there's also X dot pop, and this removes the element at the end of the list and it returns 7. So now X, it goes without 7. And then there's also other elements like X dot reverse, and now if X, you'll see it's completely reversed. And if you put X dot index, and you can put any number so long as it's a number in the list, and it gives you the index. So let's just put 2, it should give me 4, I believe. Yeah, that's correct. So the index of 2 is 4, 0, 1, 2, 3, 4. Now all of these are important, reverse, pop, append, but if you ever forget them, no worries at all. You can always just Google, and I'm sure the Python documentation will be very able to give you, will be very able to help you with this. So we're actually going to delete everything. Okay, so let's write a Python program to create a list that contains all the multiples. Actually, I'll write it down here. Okay, so it's a Python program to create a list that contains all the multiples of 5 from between 1 to 100 inclusive. So now you don't actually need to use a function, but you will need to use a list because the list needs to be returned. And anyways, it's from 1 to 100. So for I in range, and I'll actually put 101 because it's inclusive. If I divided by 5 equals to 0, I mean remainder 0, then, and I'll actually create a list before that. So multiples of 5, that's what I'll call it. And I'll create this list here. Cool. So now, oops, sorry, and I'm actually going to print it to see what we get. Just a little typo, and there you go. So that's how we use append, and we're going to use append pretty commonly because it's one of the more important Python methods. Okay, so we're going to use Python to do some practice on some questions, just as we always do. And what we're going to do is we're going to create a program. I'm going to delete this, by the way. I'm going to write a Python program that takes in 2 lists. The function should return a list of all the unique elements that appear in both lists. If there are no common elements, the function should return an empty list. Okay, hold up. Just put a full stop right there. Cool. So list 1, list 2. oh, by the way, I forgot to mention this, but basically all the arguments, all these things in the function are the arguments, so basically they can be used in the function code. Okay, so let's figure out how to do this. You can take some time to pause the video and think. So it's not that hard. It's going to return a list. We'll just call it list return and we'll define it as an empty list at first. For I in list 1, if I in list 2, list underscore returned plus equals to I. Hold up, give me a second. Or you can put dot append I. Okay. And then after you run that for loop, for I in list underscore returned, okay, you know what? This is a terrible way to do it. I'm so sorry. For I in list underscore 1, if I in list underscore 2, if I not in new list, new underscore list dot append I. And this should work. Cool. So let's run a test case. Get underscore intersection. Hold up, am I doing this correctly? Yeah, sorry, my bad. So sorry, man. Don't know what's going on. Cool, so 2, 3, 3. And then yep, that's correct. So now, even if you switch it around, let's do that to make sure that the thing works. And yeah, that works. Okay, that's good. Now, we'll actually run another test case to make sure that it really works. I mean, usually you have even more test cases than just these two, but obviously in the interest of time and just because I'm not not here to teach you how to write test code, so you won't actually be writing all that. So that's great, that's done. Okay. Okay, so I'm gonna try another interesting little function. I hope you understood that. I'm sure if you didn't understand it, just watch it again. I'm sure you will. And the second thing I want to show y'all is write a Python. Second example we're gonna go through. Write a Python function that that takes in two positive integer parameters a and b, and generates a list that contains a lists, and with each of these a lists containing b elements. Okay, you know what? To make this less confusing, I'm gonna call it x and y. That contains x number of lists, with each of these x lists containing y elements. Okay, sounds complex, right? Okay, and I'll add one more thing to make it clear. The b elements, what am I talking about? The y elements in each of the x lists are numbered from 1 to y. Okay, so for example, to make it clear, if x equals to 3 and y equals to 4, then the list generated will be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So essentially, there'll be in the list there'll be an X number, so in this case three 2D lists, and in each of these 2D lists, which is list within a list, there'll be the integers will be from 1, 2, 3, and will be from 1 to 4, will be from 1 to y. Okay, so let's try that. So I'll just call it generate 2 underscore d. Can you do that? No, I don't think you can do that. Sorry, my bad. Okay, so we'll call this x and y. Okay, y'all can again pause the video to figure out how to do it. So I'll just define a list called list generated. New underscore list equals to this. For I in range 1, y plus 1, because I want to capture all the digits in y, I'll create a new underscore list and I'll append. So I can append I. And after that, I created all the new list, which is the inner list. Okay. What I'm gonna do is I'm gonna make this equate to new underscore list times x. And after that, I'm gonna return the list. Okay, let's try it out. Okay, so that works. Let's try this with 2 and 5, and that works as well. So again, the new list, as you can see, refers to the list within. So first I create all the new list. For I in range y to y plus 1, new list or append I. So let's just say in this case it is 5. So from I in range of 1 to 1 plus 5 plus 1 is 1 to 6. New list will append 1, 2, 3, 4, and 5. So after that, all the new lists will be created. Then the list generated will equate to each of these new lists multiplied x times, which is 2 times. And that's it. Another way of typing this, okay, for I in range 1 x plus 1, and if you prefer this, you can also type list underscore generated dot append new underscore list. And that should work. Yep, that's right. So if you change this to 3 and 4, it works just fine as well. So it's a double for loop basically. First you create the inner list, then you create the outer list. Well, I mean you create the list within the list, then you create the list itself. So we're done with the concept of lists and functions, and we'll move on to our next topic. Alright, so now we're done with lists. I'm going to delete all this, and we're going to talk about tuples or tuples. So tuples are basically a data type, but it's like a list, and it is immutable, unlike lists. So you can store heterogeneous data types like strings, integers, floats, etc. I'll just give you an example of a tuple. So this is an empty tuple. This is a tuple with one element. And just take note, it's just one element, you have to put a comma. Right? And then there's also, this can also be a tuple. And this, if you want a tuple of different data types, you can also write it this way. And there's a 2D tuple of tuples within other tuples. Alright, so we can also concatenate tuples and slice tuples. So I'll just create a really long tuple, not a really long tuple, a tuple to show you what I mean, just like you can concatenate, slice a list, but you can also concatenate, you can slice a tuple just like you can slice a list. Although I'd say you can also concatenate a tuple just like you can concatenate a list. So just let me show y'all. Okay, so Now you see I just sliced it, and then I started from the 5th element all the way until the last one. So 0, 1, 2, 3, 4, 5, that's the 6th element actually. Yeah, so that's how you get it. And you can also slice it from the 2nd element to the 9th element, and we can even jump by 3, and you'll get, well, actually the 3rd element to the 8th element, 2, 6, and 1. Okay, you can also reverse it as well, and you'll get the same thing basically, but it's reversed. Okay, great. So you can also concatenate a tuple. So let's just define another tuple. And you see, alright, so you can see that we can concatenate a tuple. We can also multiply a tuple. So and you can see that the tuple was multiplied 3 times. Alright, so a tuple is pretty much very similar to a list in a way, but it's immutable. So the list methods that modify the list, such as pop, append, insert, remove, do not work on tuples. However, what does work on tuples are things like length, max, min, and sum. Nice, cool. So I'm going to write a Python function called getMinMax, and the function should return the maximum and minimum of the numbers in the input list as a tuple. Okay, so just to say that again, I'm going to write a function called getMinMaxMin, and it takes in an input list and it returns a max number and a min underscore number. Okay, so this is just an interesting little exercise that we can try out. So what you want to do is well, we're actually going to do it very simply, but we'll just use this, and we'll just use the helper function, and there we go. So we can just try it out. Basically, this is just to get you used to writing some tuples. And there you go, 8 and -2, so it works. Okay. Let's try another question. Alright, so given a 2D, okay, you know what, I'm just gonna write down the question here. Given a list of fruits with their, given a list of tuples with the values of fruits and price, find the cheapest fruit. For example, okay, so basically, given this kind of list with tuples consisting of the fruit and the price, find the cheapest fruit. Not particularly challenging, so I'm just gonna create a function. I'm just gonna create a list with all the prices. So I'm just going to change the question. Actually, the fruit returned is banana. Okay, for I in price list, price dot append. Then for I in price underscore list, if I, which is the price of every fruit, is equivalent to the minimum of this list. Actually, I think prices is a better name. Then you return that particular fruit. So let's just try it out. And I'm just gonna copy this. Hold up, give me a second. Oops, sorry, there's a typo. And there you go. Okay, so a simple question to get used to writing some tuples. Alright, so we'll move on from that. And we'll go to our next topic. So I'm just gonna clear everything here. And our next topic will be while loops. Now, I know I spoke about while loops a little bit earlier on, so we're gonna go into while loops a little bit more in depth right now because I feel we didn't really cover it well enough. So we'll talk about how to break out while loops. So for example, while loops, recall, it allows you to do something repeatedly until some terminating condition. So I'll just give an example of a for loop. Okay, so to write this in a while loop, what you want to do is total equals 0, total equals 0, I equals 0, oops, while I is less than 10, total plus equals to I plus equals to 1. And now you print total, and you get 45 as well. 45 as well. So you'll kind of get the logic. Basically, while I is less than 10, you add I to the value of total, and then I increments by 1 all the way until it's 9. So that's how a while loop kind of works. So now I'm gonna do a practice, give you a quick question, and I'll actually again convert this to markdown and write a Python function print underscore odd that uses a while loop to print all the odd numbers between two given numbers start and end, both inclusive, in a single line. Okay. Alright, so the function takes in two parameters, as you can tell. I'll just add it here. Okay, cool. So what I'm gonna do is try to do this question basically. So I'm gonna define the function print underscore odd, and we'll have two arguments, and I equals to start odd numbers equals to this. Oops, I just define an empty string. While I is less than or equals to n, if we so now we initialize the while loop, then we need to figure out if this is actually an odd number. And so we find it basically if it divides by 2 and the remainder equals to 1, then it's going to be an odd number. And this is how it goes. So if it's an odd number, we will append it to this odd number string, and we'll also append a space, and then I plus equals to 1, and now we'll return odd number. Okay, so now let's try this. Oh, my bad. So it's odd numbers. 3, 5, 7. That's great. Okay, so we can also try things like 1, 1 to make it sure it works. Wait, both inclusive, right? So that would be correct. So let's try a bigger number, a bigger difference, 2, and let's just put 19. And there you go. So that's an example of how to use a while loop. So now let's create a Python function called, okay, let's try another exercise. So write a Python function add underscore numbers that uses a while loop to ask the user for n positive integers so basically one positive a certain number of positive integers. The function, hold up, let me just type it out, adds up the total of these n numbers, prints the total, and then returns the total. The function takes in a single parameter. Okay, and just to take note, n is a non-negative integer that indicates the number of times that the function should recurse for positive integers from the user. Okay. So basically, I see what's going on. Alright, cool. So initially, there's the function. I hope this was not too confusing. So basically, we are going to create a function that gives the user the opportunity to input a number. Then, based on that number, the function will ask the user several times to indicate more positive integers. And then, um, at the end of it, it'll return the sum of all those numbers, basically. So it sounds interesting, and I think we'll actually try to do it. So def add numbers, we just create a new function n, and I equals to 1, total equals to 0. This total is the total from all the inputs. So while I is less than n plus 1, num equals to integer input, type in a positive integer. Total plus equals to num, I plus equals to 1, return total. And now that should work. Now let's try print. Oh no, okay, let's just try add numbers, and then we'll just try 3. Actually, you know what, I'm supposed to print the total. So let's put 1, 4, 3, and 6. And the answer is 10 will be printed. And that's how it works. So effectively, the argument will determine the number of times this particular question type in a positive integer is asked. And every time you enter in a number, they'll add it to this total here. And they'll increment I by 1 all the way until it's of the value n plus 1 basically. And then that's when it'll be terminated. And that's basically how it works. So okay, great. So we're going to do one final exercise on while loops before we move on. So the exercise will be write a Python function validate underscore input that takes in 2 parameters. Input underscore list list. This is a list of strings with each string containing a sequence of characters. This string may be empty, and then we'll create another list, checklist, type list. This is a list of strings with each string containing a sequence of characters. This string may be empty. Okay. Okay, now I'll also add that the function uses a while loop to check if all strings in input underscore list are within the check list. The function returns true if all the strings in input list are within check list, and false otherwise. Okay, so basically the input list needs to have strings that are in checklist to return true and false if otherwise. So seems interesting, so let's try it out. So def validate underscore input underscore list, check underscore list, and I equals to 0, while I is less than the length of input underscore list. If input underscore list I in check underscore list, let me drink some water. I plus equals to 1, else you can return false, return true. So what I did is I initialized the initial counter I equals to 0, and while this is lesser than the length of the input list needs to be checked. The element, each individual element will be checked in checklist, and then it will increment plus 1. If this condition is not met, which means that this element in the input list is not in the checklist, then false will be returned. And basically, if this condition of else whatever never runs, that means this condition is met every single time, which means everything in the input list is within the checklist. This return true will be returned. So let's actually try to validate it with some test cases. And we'll actually try one that will return true initially, and we'll try one that will return false. And actually I'll take this out, and it returns true. So now let's copy and paste this, and let's change it to this, and this returns false. Okay, now let's mess around with it, making sure it really returns true and false. Okay, that's great. So okay, so now we're going to try a slightly more complex example, and I'll actually write it down so you can try it out. Write a Python function play underscore game that takes in two parameters, bet underscore amount. This is a positive floating point number, credit float. This is a non-negative floating point number. The game works as follows. In each round, the user places a bet amount. if he or she has sufficient credit. The bet amount is then subtracted from the user's credit. The computer generates a random number between 1 and 10, both inclusive, so it could be 1 or 10 as well, and asks the user to make a guess. If the user guesses the number correctly, 5 times of the bet underscore amount is credited. So we're really making like a little game to his credit. For example, if he bets like $1, he will get $5 if he wins the round. Now the user has to stop playing when he or she has no longer when he or she no longer has sufficient credit to play the next round. The function returns the total number of rounds the user has played. So this is just like a gambling thing. So basically you have a credit, which is amount you can bet, and every round you bet an amount. If you have sufficient credit, the bet amount will be subtracted from your credit, and if you get it correct, basically you have a 10% chance of getting it correct. Basically because the computer will generate a random number between 1 and 10 and ask you to make a guess. If you guess it correctly, you get 5 times the bet amount. So you have to stop playing when you no longer have sufficient credit to play in the next round. Okay, great. So this should be fun. Let's try to do it. You can pause the video to if you wanna try it out now. But if not, I'm just gonna try to do it now. So first thing you want to do is import random and define a function bet amount credit. So that's the two what do you call that? The amount of the bet amount that will be returned every single round, 5 times that, and also the amount that will be deducted from the credit every single round. So you got to choose those two variables. So again, we use a while loop, I equals to 0. Now while credit is greater than or equals to bet amount, number equals to random.randinit 1 and 10. So what this will do will generate the random number, and the random number will be printed. So user guess will be equals to integer inputs make a guess 1 to 10, and then if number equals to user underscore guess. By the way, I don't think we won't be printing this number like when you're playing it for real, but it's just for testing purposes so that we know that the code's working properly. If number equals to user guess, the credit will deduct the bet amount, and the credit will be added. Okay, actually this is not a good way to write it. Sorry about it. So what happens is that the credit will deduct the bet amount, and credit will add bet amount if it is equal, and print correct guess current credit is then we'll add round credit 2, and we'll put an exclamation point, and else we'll just print something similar. Wrong guess, current credit is, and now at the end of every round, we're gonna add I equals to 1. Hold up, give me a second. Okay, great. So the I basically will tell the user how many rounds the user has played. So no more credits /n you have played plus string I plus rounds. Okay, so now that should work. So let's try it. So we're gonna try with 50 cents and $2 worth of credit. So now if I guess it wrongly, hold up. Can only concatenate string, not float to string. You might have even seen me make this mistake earlier. So wrong guess. Can only concatenate. Yep. So basically, what they want me to do is they need me to make this a string. And let's try that again. So, okay, great. So I'm also gonna have to change this. Hold on, give me a sec. Let's try that again. So, wrong guess again. So now the correct one is 6. I'm just gonna guess that correctly. And that's right. That's great. So I think we made a slight mistake. It's not plus the bet amount, it's plus the bet amount times 5. We'll stop this and we'll run it again. So again, 8. Now I got it wrong. Now I'll just try to get it correct. And now, correct guess. And current credit is 1.5, which I don't think it's correct, right? Because you're supposed to add more credit than that. Hold up, give me a second. Hold up. So credit is 1.5. Wait a sec. Current credit. Oh, wait, let's try this again. Okay, great. So if it's wrong credit, it's correct, but correct credit doesn't quite work. So this code is running, but it's only, let's try that again. Yeah, it doesn't really add the credit. Hold up, give me a sec. Current credit's 2. Hold up, give me a second. So sorry about this, man. I'm really not sure what's going on. Credit's not being printed. Correct guess. No, this is wrong. Let's remove this. Okay, you know what? Hold up. Bet amount. Let's create a new variable called amount, and we'll multiply this, and we'll actually print that as well. Okay. And now we'll stop this. We'll actually delete all this shit so we know that. Okay, let's try that. Now we have an issue. then it works. Not quite sure what's going on, but okay, let's try that again. We'll stop this. If you put 5, it doesn't work. 4, it doesn't work. 3, it doesn't work. Now we have to guess correctly. 6. Then now it adds 250, which is the correct amount that it's adding. Because wait. Yeah, so this is the answer. So let's try that again. Now it's completely correct, right? And then now the credit is 6.5. Now the next one will be 8.5. And if you just get it wrong and get it wrong and get it wrong, and it just deducts 7. So actually I did not really change anything except I created a new variable here that stored the debt amount, and then after that I appended that to credit. Not quite sure why it doesn't work directly. I have no idea. But anyways, that's how you do it. So I hope you enjoyed that. And what we're gonna try next is we're going to do a quick review of everything we've covered so far. So I'll just try to write out what we've covered so far. We've covered what variables are. We've covered variables, for loops, strings, lists, tuples, while loops, string slicing, string concatenation, list, same stuff. Yeah, so we've covered these few things, and what we're gonna do is crap. Give me a sec, okay? Oops. So yeah, basically we've covered a few different concepts, and what we're gonna do next is we're gonna do some questions that will help y'all reinforce those concepts more strongly. So the first question is what I would like to call a perfect squares. Okay, so a perfect square is an integer that is the square that is a square of an integer. For example, 4, 9, 16, 25 are all perfect squares because 2 times 2 equals to 4, 3 times 3 equals to 9, 4 times 4 equals to 16, 5 times 5 equals to 25. Okay, so what I want you to do is write a Python function count perfect square that takes in 2 positive integer parameters a and b and returns the number of perfect squares that fall within the range a and b, both inclusive. Nice, this better work. Hahaha. Pretty simple, be honest. Wait. Yeah. So yeah, that's right. So basically the numbers in between must be a perfect square. So I'll actually just show you how to do it. Yes, that's right. So first of all, we'll import the math library so we can check for square root easily. I'll show you why. So def count perfect underscore square a b count equals to 0 for I in range a b plus 1 if round math dot square root I power 2 goes to I. So basically, this checks for square root. So what happened is that you will square root this number, and then you'll square it again. And if it's the equivalent, that means it was a perfect square. Because if it wasn't a perfect square, then you'll give a different value. So count then will equate to 1, and now your return count. So okay, let me just explain. So the count starts at 0. Then it loops through all the numbers between A to B, including B, because it ends at B plus 1. So if when you round the math.square root I to the power, and you square it again, it goes to I, it basically just means that when you square root it, it equates to, and you square root it and you square it again, it equates to this number. So for example, if you take 9, when you square root 9, you get 3 square, and you get 3 again. And you get 9 again. So it's equivalent if it's a perfect square. However, if it was say like 5, by the way, I just realized that this, okay, you know what, sorry, just let me write this properly. So if it was say like a number that wasn't a perfect square, oops, if it wasn't a, oops, my bad, if it wasn't a perfect square, let's just say 10. When you square root 10, okay, let's just try that. You get this. And now when you power it, you'll get 10, but you need to round it. Oops. So basically this will make this particular value 3. Okay, and then now you power it, you'll get 9. So it's not equivalent if it's 10, whereas if it was 9, it would be equivalent. Okay, so basically this checks that it's a perfect square, and if it is, count will be incremented by 1, and at the end count will be returned. So let's try it. Okay, count underscore perfect underscore square, and let's try the test case of 4 and 30, and the answer should be 4, because 4, 16, 4, 9, 16, 25 are the perfect squares in between. Let's try that again, but let's try it with 37, and let's just say 47, and there are no perfect squares in between. Now let's try with 1 and 3, and there should be one perfect square. That is 1, and that is correct. Okay. Alright, so that was a quick recap of a number of different concepts. Okay, so now let's try another example. Now we'll just cancel everything. Okay, so I'll actually type out the things so that y'all can understand. In Python, variable names that contain multiple words can be concatenated using underscores, example long underscore word, or using camel casing, example long word. So write a Python function count underscore words that takes in a single string parameter s that is written in camel casing and returns the number of words that it contains. You may assume that string s contains at least one word. The first word in string s is written in lowercase. All subsequent words in string s have the first letter in uppercase and the rest of the letters, in lowercase. Alright, so basically what you need to do is check
how many words are in this particular string. So camel casing basically refers to this thing. Wait yeah, so it's either underscores or camel casing, but in this case we're just checking for camel casing. So it's pretty simple, although you could pause the video and think of it how to do it yourself. So count equals to 0, new underscore s equals to s0 dot upper plus s1 for I in new underscore s. If I dot is upper, count plus equals to 1, return count. So basically what's going on is I initialize a count 0, and what I do is I create a new variable called new underscore s equals to s0, which is the first alphabet, dot upper plus s the rest of it, but I capitalize the first letter. So what this does is basically it makes the first letter, which is typically in lowercase, uppercase. Okay, then I iterate through the string and I check that if it's all in uppercase, I'll increment the count by 1. So the number of uppercase letters basically will be the number of words in the string. So let's try it. So let's try the word camel casing, and it should return 2. And if I try the word with, like, say, alphabets, it will return 1. Okay, cool. So now y'all may be asking, how do y'all know it's upper, dot upper, all these kinds of helper functions? What you want to do is basically just Google it, and yep, that's basically how it works. So we're done with the recap. Now we'll actually move on to our next concept. And just hold up a second. It's actually dictionaries. So it's kind of our last major concept. Well, one of the last few concepts. So we're almost done actually, guys. Congrats if you've made it this far. Yeah. Okay, so first of all, what's a dictionary? Dictionaries are another mutable data type in Python, like lists. Dictionaries allow you to store a collection of items. However, the main difference is that each element in a string, tuple or list, is accessed via its index 0, 1, 2 that indicates its position in the data type, whereas each element in a dictionary is a key value pair. So just to remind y'all, so let's just say if you wanted to access the first element or the fifth element or whatever, fifth element, I'll put the number 4 and I'll get E. Right, for a dictionary, so I'll just give an example. You access it via the key. So let's just say this is a dictionary of this person, and I wanted to access her name. What I'll do is I put name and you'll return Alice. Okay, so it's also a mutable data type, so you can change it. And it's also iterable. So yeah, that's basically the main difference between dictionaries and lists. Okay, so let's try an example. Oh, by the way, one more thing is all the keys in the dictionary must be unique. If you try to add a key value pair where the key already exists, the key value pair will be updated. Okay, so let's try a very simple dictionary example, and I'll actually write it down as usual. And so it's write a function count underscore words that takes in the following parameter: s type string. So basically the parameter will be string. This is a string of words, for example,
Oops, what am I doing? Example, S equals to, is she happy or is she sad? Okay, your function should count the frequency that each word in S appears and return this information in the form of a dictionary, where each key value pair refers to the frequency that the word key appears. Your function should treat each word as case insensitive, i.e. she and she both refer to the same word. Okay, so basically this will take in a parameter which is a string of words, and it counts the frequency that each word appears in that string, and you'll return this information in the form of a dictionary where each key value pair refers to the frequency that each word appears. So the key will be the word and the value will be the frequency. Your function should treat each word as case insensitive, i.e. she and she both refer to the same word. Very simple, and it's a very common question for dictionaries because it's just the way things are. So no worries, let's try it out now. Okay, so it's one of the simpler functions. So we'll first of all, because I said your function should treat each word as case insensitive. Okay, the first thing I did is I initialized a dictionary called words, which will store the frequency and the words. The first thing I'll do is I'll convert the entire string to lowercase. That'll make it easier. The next thing I'll do is I'll split the string based on the spaces. So we have a list of strings. So, and actually, I'll try this out first so y'all can see how things are going. Okay. So now you get a string, all lowercase, as you can see here. The she was uppercase, now it's lowercase, and it's a list of, the string converted to a list, so you can access it more easily. Now iterate through in the list. And what I'll do is that I will oops. What I'll do is I'll use the dictionary key and we'll see if this works. Okay, we'll straight away try to append the key value to the dictionary, and we'll do a count of that particular word. So what we did was that looks very simple, right? What we did is we put the key inside the dictionary, and then we use the count function to count based on that particular word. So just to recall, the count function returns the frequency of the string within the string. So if you forget, count Python, because I kind of forgot actually. Okay, so return the number of times the value cherry appears in the fruits list. Okay, so in this case, S is a list. Hold up. S is a string, so you'll count how many times it appears and stuff like that, and basically this is one way to do it. And if you want another way to do it, which I'll actually show you because I feel that what's going on? Why does it look so weird? Oh, because I feel that this way it's a little bit difficult to visualize. So I'll actually delete this and I'll show you another method. which requires a bit more code to be written, but it's easier. So for word in s_split, but it's easier to understand. What I'm going to do is I'm going to check if the word is in words, and if it is, I'm going to do this, else oops, and you see it still works, right? So it gives the same output. So what's the difference? Okay, the difference is I iterate through the list just as I did, and now I check if that word in the list is in the dictionary. If it is, I increment by 1. If it's not, then I create a new key value pair, whereby I use the word as a key and I use the value as 1. And that's all there is to it. By the way, I may have forgotten to show y'all how to add things to a dictionary, so basically I'll show y'all now. Now, basically, if I wanted to add something to Y, what I'll do is I'll add something like gender equals to female. Alright, and now I'm actually going to return Y, and now gender is added. Okay, and if I wanted to update the key, so let's just say I wanted to change her age to 21, I could do that, and now when I return Y again, the age should be changed. So same thing here, when I wanted to increment or update the key value pair, I just do this. When I wanted to add a key value pair, I would just do this. So this is another way to do it. It's extremely common when working with dictionaries. We've gone through the major concepts in Python: dictionaries, lists, tuples, strings, string manipulation, variables, if-else statements, for loops, while loops. And I think that this key operators in Python, as well as these key things in this Python programming language can be applied to many different languages. And I think that now you're probably well equipped to start learning more about more complex Python topics, more complex data structures, like say stacks, queues, and other algorithms like traveling salesman algorithms that are probably beyond the scope of this particular video. But certainly, if you want to start learning how to solve like more complex programming questions on LeetCode.com or HackerRank, I think you're definitely more well equipped to do it armed with this basic Python fundamentals. If you want to start making web apps using say Flask or Django, I think you've learned everything you need to know. There's really not much else, but of course you don't know everything, and you'll just have to keep Googling and learning some of the other Python libraries, other Python conventions, and other Python frameworks. I certainly think that now that you're done with the video, you'll be much more well equipped to use Python in your own projects, and I wish you luck. And if you have any questions or